Okay, so this is our typical partial fractions. After that, you got, I believe there's a differentiation, and then there is some differentiation integration over here, okay? So partial fraction, 5 marks, we should always score because it's something you can actually check your answers for by subbing a number in the question and subbing a specific x value in the same value in the answer. Your partial fractions should be the same as this, okay? Because you're just splitting it up. You're not changing anything. The fraction is still the same thing. All right. So what I have here is that we can split this up. So this is a linear factor. This is a quadratic factor that cannot be factorized. So when you split it up, it will end up with this. And then this part here is bx plus c over x squared plus 4. Okay, so you're trying to make the denominator the same. So when I bring it down, plus 4x minus 20, okay, your a got to multiply with x squared plus 4. Your bx plus c got to multiply with 2x plus 1. Okay, so this is the partial fraction where you don't need to do long division one. So they are quite straightforward, nothing much to worry about. Okay, so what you're going to do is you can let x be a few things. So first thing first, I'll try to get rid of this one here. Okay, this one here, I will let x equals to negative half. All right. Then if you let x be, I'll fast forward, okay? When you let x be negative half, right, you will be able to solve until you get a equals to negative 5. So this part is about training your accuracy, okay? Don't keep count only, then keep getting it wrong. Next one is from here, I can let x equals to 0. Okay, when I let x equals to 0, right, I should be able to find out, eventually I should be able to solve for my c. So my c is also 0. So the last one over here, no choice already. You just let x equals to any number. I usually let x be 1. Okay, so when you let x be 1, right, then you suck in your a and c accordingly. You'll be able to get b equals to 4. So this is not something I'm very, very worried about. So, but anyway, my partial fractions will end up with my final answer. So my A will be negative 5. Okay, then my B is positive 4. And then C is nothing. So it will just be like this. Okay, so suck in your x equals to maybe 3. Suck in x equals to 3. Make sure they are the same thing. All right? Okay, so I'm going to fast forward first. Okay, so what I have here is that there's a differentiation going on here, right? Is it related? Let me see. Yeah, it's related, okay? So there's a differentiation going on here. So how do you differentiate this? So let's say I do d over dx, right? Must write ln whole thing. I cannot put dy dx unless you define that that is y equals to something. Okay, so what happens? Differentiate ln is always 1 over. So 1 over x squared plus 4. So don't forget to multiply accordingly. So multiply by the differentiated bracket, that is 2x. So I'll end up with 2x over x squared plus 4. Yep, correct. Okay, x squared plus 4, like this. Okay, so then from here, 2 marks. Okay, quite reasonable, right? Okay, so the last one, right? The gradient function. What's the meaning of gradient function though? That means this thing, right, is actually my dy dx. Okay, this thing is my dy dx. So you're supposed to find the equation of the curve. So that means you got to go backwards of dy dx, which means you must integrate. So that's why this is a hence kind of question, right? So they say the y-intercept is this, and then using a and b. So what I have here is that, so now we need to integrate, okay? So we just integrate first. So y equals to that thing, right? Y equals to integrate this 3x squared plus 4x minus 20 over 2x plus 1, x squared plus 4. So the important thing you need to understand here is integration don't have so many rules. One don't have quotient, don't have product, right? So what you need to do is got to use what you did in the beginning. So what do you do? This thing, right? This thing over here is exactly the same as this, right? So that means what you need to integrate is you need to integrate this guy. Okay, you need to integrate this guy over here. So when you want to integrate this guy here, okay, some scary things to see now because, right, what I have here is, okay, I can integrate this one. This one, no problem. Because this one is power 1, right? So you must remember whenever it's power 1, it will become a ln. All right, so negative 5 ln 2x plus 1. Don't forget to differentiate the bracket. So divided by 2. So this is the yellow one. But this blue one over here, right, cannot be integrated as per normal because it's not like what we learned, right? So you need to use part B. So for part B, right, let me just pen out over here. For part B, when you integrate this guy, okay, when you integrate this guy over here, what will you get? You will get ln x squared plus 4, then got a plus c here, right? But it looks a bit different because this one is 4x. How do you make it 4x? Just times 2, lor. So when you times 2, right, then it will be extra 2 over here. Okay? So then when we integrate, we can just bring this down. So this is 2 ln x squared plus 4, like that. Then there's no boundaries, right? Is there boundary? Don't have. So put a plus c. So this is your important integrate hence kind of question. Use the top. Okay? So we got all your different hands going on here. So now we have this ready, right? What we have here is that the y-intercept. So you start in, x equals to 0, y is ln 4. Let's try. So ln 4, because must solve for c, right? Negative 5 ln 1, because x is 0, right? Like that. This is 2 ln 4 plus c. So if you key calculator for ln 1, right? Ln 1 will just give me 0 leh. So then at the end of the day, you end up with this equals to this. Okay, this equals to this, right? Oh, there's a plus there. Okay, like that. So now, right, how do you combine these two together? If you bring to the left, right, is one set of ln 4 minus two sets of ln 4. So this part here will just become negative one set of ln 4, like this. So eventually your final answer, you can put this in, but then you put in your negative ln 4. So this will be my final answer. Okay? So this is an important hence question. Usually it's a killer for most students. So with partial fractions, you also can do hence integrate. For this one here, differentiate already, right? You integrate the answer to get back your this one. That's how we end up with this part over here.